What's the difference between dark matter and antimatter, or is it the same thing? Well, dark matter and antimatter are not the same thing. And so, what is dark matter? Dark matter is a missing. It is an unidentified component of the mass energy composition of the universe. So let me show you. Let me share a screen with you. Okay, let's take a look at this. So this is the matter energy, mass energy composition of the universe. About 4.9% of the universe is ordinary matter. So this is everything we can see in the universe. All the planets and stars and nebulae and galaxies and all other luminous matter. This is just 4.9% of the actual universe. So we understand less than 5% of the actual universe, right? More than 95% of the universe is entirely unknown to us. We do not have the even the basic understanding of what it is. We know the composition. So about 26.8% or thereabouts is what we call dark matter, and the remaining portion, about 68%, is what is called dark energy. Now, dark energy is a really mysterious thing. Dark matter is slightly better understood. It is something that interacts only gravitationally. It does not interact via the electromagnetic interaction or the weak interaction or the strong interaction. It only interacts with ordinary matter via the force of gravity. So this could be some form of purely gravitating particle, or it could be a family of particles. We seriously don't know at this point. We have a number of theories, but as of now, there is absolutely no direction. There are many theories. Some are more so some theories are more in vogue right now, some theories are less in vogue, but none of these theories has ever come close to being proven or in any way at all. So that is what dark matter is. And how did we discover dark matter is an interesting story. So when we look at galaxies, we can calculate the amount of mass in a galaxy based on we can calculate the amount of mass in a galaxy based on the light output of the galaxy. So we can estimate the number of stars and the mass that is in a galaxy, and then and we know that galaxies, they rotate around their axis or around their center. So based on the laws of physics and the amount of mass a galaxy contains, based on the light it emits, we can tentatively estimate or predict how fast its arms will be rotating, how fast they will be going around the center of the galaxy. And the predictions never match observations. The predictions are are supposed to be in line with Kepler's second law, in case you have studied that. But what we find is that it doesn't work that way. The galaxy's arms move at a very different rate. So let me show that. It's called rotation curves, and this is what it is. So this white dashed line over here, if you can see my pointer, the white dashed line is what we expect from the visible disk of a typical galaxy. This is based on estimations, on calculations, based on the laws of physics and based on the amount of matter we can observe. And what we see is very different. The yellow and blue points are observational evidence, and they are very, very different. So the rotation curves of galaxies are very different. They rotate faster than what we would expect them to. And the best way to explain this discrepancy is to hypothesize that the galaxies contain some invisible matter, which far exceeds the visible matter. So this is what we call a dark matter halo, and this explains the discrepancy in the rotation curves of galaxies. So this is how the idea of dark matter first emerged, and then now we have seen other evidence of dark matter, for example, gravitational lensing, etc. So that, in brief, is dark matter. What is antimatter? Antimatter is essentially antiparticles. See, ordinary matter like us, right, or our bodies, etc., everything we know is composed of subatomic particles, protons, neutrons, electrons, and so forth, right? That is our ordinary baryonic matter and hadronic matter. Now, antimatter is composed of antiprotons, antineutrons, anti-electrons. So an antiparticle is has the same exact same mass as a regular particle, but its charge is flipped, it's opposite. So an antiproton has a negative charge and the same mass as a regular proton, which has a positive charge. An anti-electron or a positron has a positive charge and the same mass as a regular electron. And anti-neutrons also exist, which have anti-quarks instead of the regular quarks, which make up a neutron. So antimatter happens, it manifests itself at the baryonic level and even at the quark level. So that's what antimatter is. It's essentially, it has opposite charges, and certain quantum numbers are also different, but the masses are the same. So an anti-proton and a positron could get together and combine to form an atom of anti-hydrogen. So that's what antimatter or antimatter is. The thing about antimatter is that it immediately annihilates when it comes into contact with regular matter. So if a proton would come into contact with an antiproton, they would immediately annihilate each other and give off photons. So these two masses, they will combine and produce pure energy in the form of photons, by the very famous equation which we all know, E equals mc squared. So it is very difficult to so antimatter has been observed. It is produced regularly in large colliders, such as the Large Hadron Collider and other such instruments. It's also emitted in certain forms of radiation. For example, you have positrons that are emitted from certain kinds of radiation, which has given rise to this technology called positron emission tomography, PET. You know about the PET scans, PET scans. So that is a technology which has been developed because of the emission of positrons, which is antimatter from radiation. And so there are various ways of producing antimatter, but it is very difficult to store it because, like I said, the moment it comes into contact with regular matter, it just explodes. It gives off a large amount of energy. So to store antimatter, you would have to confine it in a pure vacuum. You cannot even have a single molecule of oxygen or nitrogen or anything in there, and it has to be confined in the center of a container which has vacuum. So you would need some form of magnetic field to confine it there. So it's very difficult to produce any significant quantity of antimatter, and it's even more difficult to store it. So that is what antimatter is. Dark matter and antimatter are very different things.